Well, hello, LinkedIn, X, YouTube, Twitch, and Facebook. My name is Frank Lavinia. You can catch me at the following URLs: um, franksworld.com, datadriven.tv, and impactquantum.com. Each one of them are actually having banner months. Really good times. Really good times. Um, Speaking of really good times, I just found out about this morning. So I live in Maryland, and they just announced the Frederick Quantum Frederick. It's going to be a data center, data park type operation in the county next door to me. So I'm hoping that this will lead to a lot of really cool content for Impact Quantum, and connect with various startups and things like that, and talk to them. And I am very excited about that. Today, I don't want to get too wrapped up about that, but as many of you know, I have a DGX Spark, which is probably going to be my Christmas gift, my Father's Day gift, birthday gift, anniversary gift, and probably a few more holidays to come. But I was very excited to have it. Let's see, can I swap out where I am? Maximize, oh, minimize. All right. So right now you'll see this is the state that it's in. Um, I did have, I don't know if it's still running or loaded in memory, but let's see if this will work. So one of the best things, honestly, about let's see, one of the best things, honestly, about the DGX Spark is you have these playbooks. So if you go, anyone can access them, and strictly speaking, you really don't need a DGX to do this. But these are basically playbooks, kind of like labs that you can do on your device. And obviously, if you don't have one, can't do it on your device, but you get the idea. And you go here, and this is the one I just did overnight. So if you saw me on LinkedIn, I posted that, hey, I'm kicking off a training job, and so I did actually. And thank you for the folks that told me that I didn't have to use this to scan the temperature of the device. There is actually it's actually in the NVIDIA SMI command line, and I can show you that in a minute. But here's the basic idea. This playbook demonstrates how to fine-tune FluxDev 12 billion model with a multi-concept Dreambooth LoRA, low rank adaptation. So the idea is that you will be able to teach it how to draw something very specific. You basically teach it on that. And the goal here through the instructions, you can kind of walk through and things like that. So I had basically run this through my fine tuning experience last night. So that takes about, based on the timestamps, I would say probably about 3 hours would be a good guesstimate of how long it took. So with that in mind, let me see if I can do this. That's close enough, right? Um, so let's go to here, and now there are instructions here on how to get this running, get this set up. But if you're not familiar with Comfy UI, I highly recommend you get comfy with Comfy UI. The user experience is very daunting. But the gist of it is that you create these workflows. Let me see. Hopefully, you'll be able to see that. This includes two workflows in here, right? The base model and the fine-tune one. So this is a good demonstration. So you'll see right here, it says Toy Jensen holding a DGX Spark in a data center. And if I go here, you'll notice it's more or less the same prompt. However, you have certain keywords here that you don't see in the original. So let's kick this off. I'll hit run, and it takes about 90 seconds for it to run on the Spark. And so what I will do while that's working is you have these workflows that you define, the pipelines and whatnot, entirely here, entirely graphical. It is at the core of it a JSON file, right? These workflows. But you'll see what'll happen now is it's going to go through and do that. And the nice thing about this is I can at any time take a look and see how busy the GPU is. Looks like it's loading it. And any second now, this should shoot right up. I love it. I love doing these live because you never know what's going to happen. Go. So you'll see the queue is running, and we'll just wait for this. It's basically, you'll see what highlights what's running at any given time. And the final result will be here. And we'll give it a minute to process through it. But that's basically the gist of, this is image generation. Now it's image generation on device locally on my own home network. So yay me. But the important thing here is that you can then fine tune it. So how that happens, and I was hoping it would be done by now. So that's not cool at all. What's interesting is the instructions say it could take up to 3 minutes. So I've never had it take that long. So if you go into the code here, what I'm actually doing now is that this is building the inference and this is running it here. This is a code I should run if I need to kill the memory, but I don't think I do. I don't think it's not really running out. There we go. So now it's actually doing the processing. So you'll see that the memory is at 84 gig. It is at 96%. And that means it's chewing through it. So let's go here. And yep, there it is. There's our answer. So this is not the image that it's supposed to show. This is, if you've seen any of the NVIDIA content, they always have this little, what looks like a bobblehead of Jensen. So what you then do is you go through and you run through this training or fine-tuning process. And it's all pretty well documented here. And basically you have a trigger phrase called TGA toy, and it's 6 high quality images of toy Jensen figures. And you also have 7 images of DGX Spark available in the public domain. And you have this this TOML file, which let's see if I can pull up the GitHub for that real quick. There it is. So all this is on GitHub, which is really cool. And if I go to the files, Flux fine tuning, assets, it's actually Flux data. Yeah. So this is a TOML file, which basically says this is kind of metadata. These are the data sets that we have. And the data set subset is going to be, these are where the images are. These are the tokens. There's tokens that are associated with this class. And it will pull down all of these images. So for instance, here is an image, one of the images, right? It's that toy. Here's another one. Here's another one. And if we go up, we'll see here's the one of the spark. So this way it knows what a spark is. And it looks like you can even have extra text and things like that in it. Doesn't seem to matter if there's other text there like it does has here. All right, so you go through and you run the script here that does the training. And this is the launch train shell script, which if I go back to here, launch train shell script, This will basically spin up an environment that will use this and then basically output this to a subfolder on the box. And that is what we're going to switch this to when we run here. So in order to not confuse things, hopefully I haven't, we're going to go to workflows and we'll go to fine tuned. And this is going to have the different LoRa that's there. So if we look here, this is the load LoRa. I don't think this has a load LoRa module. It doesn't. All right. So what we're doing is we're taking the base model, the checkpoint, the flux devs, safe tensors. We're attaching a LoRa to it. And I could probably choose some different ones, but this is going to be the final one. All right. Now I give it more or less the same prompt, but here's the tokens that kind of say, no, no, no. I have something very specific I want to show you. Now when I hit run, and this is going to take another, 90 seconds to 2 minutes. Let's see. We'll share this tab instead. We'll see that this is busy. This is running. That is going. And then we'll go here because just to prove that it's working, right? We'll see this come up. Now the next step, I'm going to try to talk while this is going. The next step for this is to put in my own pictures and then retrain it again and see what happens. Now the next thing I want to show you once this is done, I got to work on my timing on this. So the next thing I want to do is set it up so I can take my own pictures, right? So maybe pictures of my kids, maybe, stuff I don't want to necessarily put in a cloud, right? I want to keep my data private and I want to do that, right? Maybe I'll do my dogs. I'll do that as a demo, take a picture of my dogs in these different environments, which is actually something a coworker of mine did with his dog with another Dreambooth setup. I don't know if he used Dreambooth exactly, but he used something very similar to it. And we'll just wait here for it to run. But yeah, so if you've not already liked, shared, and subscribed, please do. You can go to franksworld.com to find out more. I am really excited to find out I live basically between the College Park setup for quantum computing, lab there, and this quantum data center lab. All right, here you go. And there is our completed results. You'll see that that is, in fact, the toy Jensen, and that looks an awful lot like a DGX Spark. And if you go to the queue, you can kind of see how long it takes. So, 3 minutes is about right. What was weird in the previous runs I had it took about 97 seconds. So let's try it again. Maybe it just has to load up. Let's see. TJ Toy holding a Spark GPU in Times Square. Let's see what that looks like. And the cool thing about this is I can queue these things up. So I can now say, you know what, in honor of Maryland, I'll say I'll say Baltimore, Maryland. Baltimore. All right, we'll run that. And then while we wait for that to cook, I can show you a really neat trick that I discovered. And I will get to go start up another shell. And I'm excited about this. This is just so much fun. Because what's really fun about it, I was slacking with a coworker, and I was like, I don't have to think about the money I'm spending on this, right? Because if I was doing this on like a public cloud, I would have to be dropping real money on this. And I already dropped the money, right? The economics are a little weird. All right. So We all know about this NVIDIA SMI. And this basically will show me a bunch of data about this, right? The power usage, the temperature, which I didn't know was there, the performance level that this is in. Right now, P0 is the high performance version, but it turns out that I can also have this automatically refresh every second. So I was upstairs, on the laptop watching this kind of go up. And so it's telling me now that the temperature, in case you can't see, is 82 Celsius. It's somewhere hovering around 83 C. And if I go and I point my little thermometer there, I get 44.7 on the top of the box. Front of the box, I'm getting 31. Bottom, I'm getting 48. And then on the back, let's see what we get on the back. The back, I get 52. So either this is completely inaccurate, the sensor in there is completely inaccurate, or there's just real differences in temperature. And if you know the answer to that question, I'd love to know personally. All right. So you'll see it's still chewing away. It claims that it's at 96% utilization, and it is according to that. And let's switch back over. There is also a shortcut. If I just want to see the temperature, I can do that. So I can just kind of hovering around high 80s, high 70s, low 80s. So let's switch out now what we are sharing and go back to this tab. So this did take 96 seconds. So maybe it just, the first one takes a little longer. There's the picture of him in Times Square. At some point, maybe there'll be people dressed like him around at Times Square. Who knows? And I've noticed this happens a lot. Even though I said there's two interesting artifacts here. It knows that it should put something there on the actual Spark device, but I said Baltimore, and it didn't work. And you'll see that it does kind of get something that looks like NVIDIA, but it's interesting how it knows that that's something supposed to be there. So I did this before, and if I put in Inner Harbor, it will change that. It's interesting how it interprets things. I posted on social media the picture of the dachshund. I wanted the dachshund to be in the picture with Jensen, but it made a dachshund that looks like Jensen and put it on the Spark. So it's very, very strange. So let's try the more famous city around here, Washington, D.C., which I think is timely given the recent conference. And you'll see that I am getting pretty much up there in terms of memory usage. And we should be about 60 seconds in now, maybe 90 seconds. So I was able to watch this. Obviously, I let it sit overnight. Based on the timestamps of the files, it looks like it maybe only took 2.5 hours to run through the whole thing. Which point I would imagine this would have gotten quite toasty. I do wonder. Uh-oh. Hang on. Something funny is going on with my speakers. All right, turn those off, and there it is. The prompt for that, I think, was Baltimore Inner Harbor. This time it just didn't take. But you see, once again, it knows that there should be a logo there, should have some color to it. And that took 96 seconds, and I would imagine this will work too. But anyway, it's a fun little thing. It's not perfect. Maybe I need to put more time into the training of it. Maybe it's the fact that it's been quantized down. No, actually, no, it's 16. floating point 16, so it should be not an issue. What are we tracking on our temperature here? I wish the dashboard here also had temperature. I don't know why I'm just OCDing about that, but let's see. It's at 82 Celsius. So let me know if you have any questions. Be sure to like, share, and subscribe. And I'm not sharing anything right now. What the heck, man? Stop sharing. So here I am. I'm blabbing away, and you can't see what I'm doing. Let's see. Let's try it again. All right. That was weird. Yeah, let me know if there's anything you'd like me to see me do. If you wanna, we can kind of work through it together. But what's interesting is that there are some, I wouldn't call them errors in the documentation. There are just things that it just makes the assumption that you would do. Now, maybe I was only half paying attention when I went through the steps, which, shame on me. But when you do that, when you do have the downloads, you have to have the Hugging Face token kind of set up, and one of the models is gated. So I kept getting this error about the header is too big. And I'm like, what's going on? So I looked at the file, and it was just an error message saying like, hey, this model is gated. So that's really all it was. And here you go. Share this tab instead. Let me double check that I'm sharing it. And this looks like you're inside the White House, which is kind of apropos given how Jensen has been flying in some high circles lately. But you'll see, it's remarkably consistent on the actual hardware. It is strange how he disappears from this. But yeah, so I thought I would share that. I had that working yesterday. And I'm very excited about it. And like, it's cool because I don't have to worry about, oh my God, I left that instance running. Nope. Because it's here. I already blew the money. Right? If that thing's not burning hot 24/7, it's kind of a lost cause in terms of the money. I don't know. Maybe I'm being overly cheap with it. But hopefully you had you learned something. Be sure to like, share, subscribe. I should probably have a fancy graphic here that does that. While I have you, and this is relevant, I promise, what I really should do is figure out a way to get them to power this thing partly on solar, right? 100 watts, probably wouldn't power the whole thing. I probably need 3 of these, but one of my long-term goals is to build out a I think it's the 8-bit guy or something like that. He basically has his home workshop and lab that can alternately run on solar power. And I'm like, yeah, that's what I want, right? That's what I would love to do. That's so check it out. I have this kit. It's really cool. I have this in conjunction with this. So I can charge up this battery and kind of travel on a plane, not worry about the FAA stopping me from boarding with it because it's just under the limit and helps me stay charged wherever I go. Don't have to rely on a port out there in the real world that I can get my data stolen on. It's completely, if the data is going to get stolen, it's probably going to be stolen through far more advanced supply chain attacks. But yeah, with that in mind, I'm going to sign off because I got some articles I got to finish up, and have a good one.